We are back at AP Review. This is 2011 BC Free Response 1. It's parametrics, and it is a calculator question. At time t, a particle moving in the xy plane has position x of t comma y of t, where x of t and y of t are not explicitly given. For t greater than or equal to 0, dx dt is 4t plus 1, and dy dt is sine of t squared. At time t equals 0, the position is given as x of 0 is 0 and y of 0 is negative 4. All right, so first thing I did, right, is I put this guy in as my x1t in my calculator and this guy in as my y1t in my calculator, right? And I've actually already done that, so I'm in parametric mode. Obviously, I'm in radian because why would you ever not be in radian in a calc class? Cool, so I put that stuff in there. So remember that on these calculator problems, your job is primarily going to be to write the correct formula, the correct integrand, the correct whatever, and then type, and your calculator gives you an approximate answer. So part A, find the speed of the particle at time t equals 3. Find the acceleration vector of the particle at t equals 3. So we're asked to find two things, and a big thing here is that if we're not careful, we accidentally only do one of the two prompts. So two things. Thing number 1, speed, right? And thing number 2, so I'm going to call this like prompt A number 1 and prompt A number 2, I'm asked to find the acceleration at t equals 3, right? So I'm asked to find speed at t equals 3 as well, right? So it's important to know what the formula for speed is in general, right? The formula for speed is the square root of x prime of t quantity squared plus y prime of t quantity squared. So except here, we want x prime of 3 quantity squared plus y prime of 3 quantity squared, right? That's my speed, right? So my speed at 3 is going to equal this, right? And I'm going to type that in my calculator in a second, but that's the first thing. Like, I need to write that this is what I'm putting in my calculator, and we'll talk about how to do that in a sec. My acceleration at t equals 3, right? The vector for acceleration is essentially going to be x double prime of t comma y double prime of t. So my vector is essentially going to be x double prime of 3 comma y double prime of 3, right? It's my job to have that, and then again, I'm going to make my calculator do all of the actual number crunching. I'm going to get answers there and there. So again, I need to communicate these pieces of information and then type. So let's talk about how to type these things in my calculator. So here, right, I want to find x prime of 3, which is my given value of x, right? I want to find that squared. So notice that this, right, so this is going to be this value is what I called x1. So this is x1t of 3 quantity squared in my calculator notation. And this is y1t of 3 quantity squared, right? That's what I want for these things inside the square root. So I just want the y and x value for the given parametric. So I'm going to go ahead and zoom 6 just so we can see this thing. I can find those x and y values really easily. So if I graph this, right? So I graph my parametric curve. If I hit trace and hit 3, that'll give me when t is 3. So that actually gives me the x and y coordinate right now. Now the x is a 13, so I don't have to store that as anything, right? So actually I'm just going to give myself one more line of work here. So this is going to be a 13 squared. I don't need to store 13 because I can just type a 13, no big deal. But the y is not a pretty number, right? The y is not a pretty number at all. So what I'm going to do is if I quit out of this and I hit alpha y, currently that y value is stored as y, right? So what I can do, right? So again, that's approximately this 0.412 squared, right? But I can actually do that on my calculator. I can do second square root. In fact, I don't even have to store them because I'm going to use them right now. If I do x squared plus alpha y squared, that's what scored, oh wait, sorry. I forgot that I was in parametric mode, so it was a t. So I did x squared plus y squared in the square root. That's actually going to be the x and y that were already stored. So I'm going to get that this is approximately a 13.006 or 7. That's my speed. So they need to see this and they need to see this. They don't need all this stuff in the middle, right? That's for you to figure out how to find the values. So the easiest way to find these values, since they were just the x and y value of my parametric curve, again, were to hit trace and then enter 3 for t, and then this value became x in my calculator, and this value became y. So I was just able to type in the square root of x squared plus y squared. Since I didn't have to use them again, I don't have to store them. So for these guys, the trick is that what I want to do is derive this thing with respect to t, right? I want to derive this thing with respect to t. Well, my calculator can do that, right? So I want to I want to essentially derive my x1t with respect to t, right? Well, there's a way to do that in my calculator, and here I want to derive my y1t with respect to t. There are two ways to do that, right? And again, that would be at t equals 3, and that would be at t equals 3. There are two ways to do that in your calculator. In this case, because I already have the graph, I could second calc, and what you'll notice if you second calc is your calculator lets you find dy dt, dx dt, and dy dx for parametric curves. They don't let you do a whole bunch of other stuff, but they let you find this. So if I pick dx dt, and then I pick at the moment when t is 3, that's going to give me the derivative of x with respect to time for the derivative of x prime already, which would be x double prime at 3. So that's going to be a 4, right? So again, what I did is I did second calc, right? And then, so if we go back to second calc for a sec, I picked dx dt, which was 4, right? I picked dx dt, right? And then I hit 3 and hit enter because that 3 was the t value. And I was given that dx dt was 4, but again, my dx dt, if I'm deriving the first derivative, I'm getting the second derivative. So I'm going to do the same thing, but I'm going to do it with dy dt. And again, I'm going to hit t is 3. And if I do that, I get a negative 5.466 or 67. And again, what I did was this exact same thing, except instead of dx dt, I picked dy dt, right? I used dy dt, right? Now, there are other ways to do it. You could do math 8, which is n derive, and you could derive x1t with respect to t. So the other way to do this, right, the other way to get this 4, if you prefer it, is you could have done math 8, which is n derive. You could have gone and gotten x1t with respect to t at 3, and you'd get the same answer. And you could do the same thing here where you do n derive, sorry, I slide that over for you, n derive of y1t with respect to t at 3, and you'll get the same answer. Again, you can either use the derivative function in the graphing section of the calculator, or you can do the derivative under math 8. Either of those are fine. Cool. All right, so that's part A. Notice that more of my time was spent here communicating how to put it in a calculator for you than anything else. You want to make sure you communicate the correct formula, but again, if you don't know how to put this in your calculator, you're going to be pretty miserable. All right, part B. Find the slope of the line tangent to the path of the particle at t equals 3. So there's a couple ways I can do this. I already have those, so I already have those two numbers. I have y prime of 3 and x prime of 3, right? So remember that when you want to find, so first job you have is to communicate what they're asking for. They're asking you for dy dx at t equals 3. Well, that is going to be y prime, so you can use dy dt or you can use y prime, right? Y prime of t evaluated at 3, my bad, over x prime evaluated at 3, and that's fine. There are two ways to find these things, right? You already actually used these once, but we saw the easy way to find this before, right? If I go to my graph and I just hit trace, right? If I just hit trace and then 3, enter, because that'll be t is 3, I'm going to get an x and y value. So I hit trace, I hit 3, enter, and that's going to give me an x and y value. So now x and y are x prime of 3 and y prime of 3 respectively, because again, x prime and y prime are what I put in. So essentially, I can just type in my calculator y on top of x, and I'll get the answer I want, right? So if I quit out of this and I do alpha y divided by alpha x and hit enter, I'm going to get that this is a 0.031 or 2, depending on if you round or truncate. And that's it, right? They want to see this setup. They want to see this and this, and that's it. Okay, so how you find those values is up to you, but again, it doesn't make a whole lot of sense to type the numbers in here. It makes a lot more. Now, you could have, right, if you wanted, you could have said, hey, you know what, I'm just going to go old school. What's the sine of 9 divided by a 13? And you're still going to get that. Like, that's also totally fine. Just keep in mind that these are much nicer curves to plug into than some of the ones you're going to see. So it's good to know how to do it strictly on a calculator without doing a bunch of work by hand. Part C. Find the position of the particle at time t equals 3. Okay, so this is using that first fundamental theorem of calculus, right? So when we talk about C, right, if I integrate x prime of t from 0 to 3, right, because they said at 3, so if I were to integrate x prime of t with respect to t from 0 to 3, based on the first fundamental theorem of calculus, I would get x of 3, which is the value that I want, minus x of 0, which is a value that I was given at the top of the problem. So essentially what I'm going to do is add x of 0 over plus the integral I'm going to make my calculator do, right? And that'll give me x of 3, right? So this is a 0 plus, I'm going to find this number with a calculator, and that's going to give me x of 3, right? And we're going to do the same thing with y in just a second. So the way I type this in my calculator, right, we've done this a couple times now. I'm going to do function integrate, which is math 9, right? x1t with respect to t from 0 to 3, right? And then the nice thing is I'm just going to hit second enter, and I'm adding it to 0, so it doesn't really matter, but I'm going to go ahead and hit math 9, right? Vars over to y vars, parametric x1t, comma, with respect to t from 0 to 3, right? And I hit enter, and I'm going to get this a 21. So I get that x of 3 is a 21, right? But they wanted the position both in terms of x and in terms of y, so if I slide this guy over for you for a sec, the same thing's going to be true with y, except instead of integrating x prime of t, I'm integrating y prime of t. So I can pretty much skip to y of 0 plus the integral from 0 to 3 of y prime of t dt equals y of 3. As a side note, if you're able to skip to this step, if you don't need to start with this first fundamental theorem of calculus because you know this is what's happening, that's dope and totally awesome. So I'm going to go ahead and type this in plus whatever the crazy thing is, and that's going to give me y of 3. So what I want you to notice is I can just hit second enter here and change this x prime of t, or this x1t. So all I'm going to do is do second enter, and I'm going to change to a y1t instead of an x1t. That's the only difference. So if I hit second enter, I don't have to redo all my work. I can just go to where x1t is, go to vars over to y vars, parametric, and pick y1t. And then I hit enter, right? So I'm going to get an answer, and then I'm going to add that to -4. And I'm going to get that it's a -3.226. So this was like a this was like a 0.773 blah blah blah, but I don't really care because what I care about is that y of 3, sorry, my handwriting is tragic, is approximately a -3.226. So that's what they need for the position. They need x of 3 and y of 3, and now you have it. Cool. So if you want to write it in x comma y, you could call this 21 comma -3.226, but I would argue just finding x of 3 and y of 3 would be sufficient. All right, cool. Part D, find the total distance traveled. So the nice thing about total distance is really just integrating speed, which you already have a formula for, right? So what you're going to do is you're going to write what the speed formula would be, right? But not, when we did speed in part A, we did it specifically at 3. So for part D, right, the speed formula is the square root of x prime of t quantity squared plus y prime of t quantity squared. And we're going to integrate with respect to t from 0 to 3, right? And that's all I have to write, right? And if you want to call this dx dt instead, and you want to call this dy dt instead, that's fine, right? They've used the two notations interchangeably in this problem, so that's just fine. So I'm going to type that in my calculator. When I type it in, it's going to be function integrate, which is math 9, square root x1t squared plus y1t squared, close the parenthesis, with respect to t from 0 to 3, right? And again, the AP only wants to see this, right? They don't need to see how you put it in your calculator, but if you're wrong about how you put it in your calculator, it's not going to work well. So I pick math 9, right? I put a square root, vars over to y vars, parametric x1t squared plus vars over to y vars, parametric y1t squared, close the parentheses, from t, with respect to t rather, from 0 to 3. And they did say from 0 to 3, they did, and it's calculating now. And I should get a 21.091, which I do. So 21.091, and that's my answer.